Okay, let's unpack this. Um, you know that feeling, just being buried under spreadsheets, wrestling with typos, missing values, just, yeah, mountains of messy data.
Oh, yeah.
Maybe you've tried pulling numbers for a report, a really critical one, or even worse, kick off an AI project, only to find the data is nowhere near usable.
Mm.
That struggle, that kind of invisible drain on time, on resources, that's the pain of poor data quality. It's huge. And it touches, well, pretty much everything we do with data.
It really, really is.
Yeah.
Data is supposed to be this, powerful engine for modern business,
Yeah.
right? Driving insights, innovation.
Right.
But so often, cleaning it, preparing it, it just feels like you're endlessly tinkering with these broken parts. And the traditional ways of fixing it, building complex rules, doing manual checks, they just haven't kept up. Not with the sheer volume and, frankly, the complexity of data today.
Yeah, it feels like you're constantly building a wall, only for like new data to immediately find the cracks, doesn't it?
Exactly.
But what if? What if the very tech that needs clean data AI could also be the key to getting it clean?
That's really the core idea we're digging into in this deep dive. We're looking at some recent articles, analyses, suggesting AI, especially, generative AI, isn't just improving things slightly.
Mm-hmm.
It's fundamentally transforming how we handle data quality.
Yeah, these sources really get into why the old methods fall short. And then they lay out pretty clearly how AI is bringing these, well, revolutionary changes, specifically in 3 key areas.
Yeah.
Data cleansing,
Mhm.
anomaly detection, and also understanding the journey of your data lineage.
Okay, so our mission today is to see how AI is stepping into this messy world, trying to move us away from that super frustrating garbage in, garbage out thing
Yeah,
towards something that looks, well, hopefully a lot more like garbage in, perfection out. Maybe that's too optimistic.
maybe.
Yeah.
But let's definitely explore it. So maybe let's start by really zeroing in on that initial problem, why the traditional toolkit is just struggling. Okay. Yeah, one statistic from the sources really jumped out at me. Data now drives everything, every click, transaction, interaction, but getting it usable.
Yeah,
That's the bottleneck.
totally.
The sources mentioned data cleaning alone can eat up, wait for it, 80% of a data practitioner's time. 80.
It's wild.
I mean, imagine having that time back to actually analyze the data or build models or, do the interesting stuff.
It's staggering, isn't it?
Yeah.
And the cost, it goes way beyond just wasted time. Poor data quality,
Mm.
it directly leads to delayed AI, machine learning projects.
Mm.
You just can't train models on bad data. Simple as that.
Right.
It results in inaccurate models giving you, well, wrong insights. It wastes technical lean time folks stuck on grunt work. And ultimately, it means missed business opportunities because you can't trust the data you're using for big decisions. It kind of undermines the whole data-driven dream.
Yeah, it's like trying to build a skyscraper on, I don't know, quicksand or something.
Yeah.
The sources use this hypeful framework. They call them the 4 eyes of dirty data.
Yeah. It's a simple way to frame it, but pretty effective. The first is inaccurate data. Pretty straightforward. Incorrect or misleading info.
Like typos.
Yeah, typos in an email,
Uh,
a product code that doesn't exist, or, yes, the classic, someone's hire date listed before their birth date. Data that's just plain wrong.
okay, that higher date one is always a good catch.
Yeah.
Right. Second eye.
Incomplete data. This is where critical info is just missing. Blank fields in a customer profile. Maybe a transaction record without a price, product description that's empty. If you don't have all the pieces, you can't see the full picture, right?
Mhm.
Or use that record effectively.
Makes sense. Then there's inconsistent data.
Mm-hmm. Same info, but represented differently. Like John Smith versus J. Smith, or different date formats of, slashes versus dashes versus words.
Date formats.
Or different ways of listing the same city. This makes trying to combine data from different places a real nightmare.
I can imagine. Okay, what's the last one?
Incompatible data. So this is data that's structured or formatted so differently across sources that you just can't easily integrate it. And it's not just different formats. Sometimes the fundamental structure itself stops you from combining it meaningfully without a whole lot of rework.
Got it. So inaccurate, incomplete, inconsistent, incompatible. And these problems are like everywhere. For years, we've relied on traditional methods, the rule-based systems, statistical cleanups. Why aren't they cutting it anymore?
Well, the core limitations are pretty clear in the sources we looked at. Traditional rules are brittle. That's a key word.
Brittle, meaning they break easily.
Exactly. A rule that's perfect for one data set or maybe one region, it just breaks as soon as the data changes slightly, or you bring in a new source, you're constantly having to manually update them.
Yep.
They're also fundamentally context blind. They work on predefined patterns, they don't understand meaning. It's Apple in this text field, the company or the fruit? A rule just sees the word apple. It has no idea.
And with all the text data flying around now and other non-tabular stuff, those old rules just don't know what to do with unstructured data.
Precisely. And all of this leads back to that massive maintenance burden we mentioned.
Yeah.
Keeping these rule sets updated across pipelines that are always changing, it's incredibly resource intensive.
Yeah.
And they often have pretty limited anomaly detection. Usually it's just simple thresholds, which miss subtle or complex issues that don't fit some basic pattern.
Okay, so traditional methods. Brittle, blind, can't handle the scale or variety. Enter AI. How is it changing data cleansing specifically?
Right, this is where the sources really highlight what AI brings to the table. Things like contextual understanding, adaptive learning, and crucially, natural language capabilities. It's not just automating the old way, it's enabling a totally new way to clean data.
Contextual understanding, that sounds like it directly tackles that Apple problem.
It absolutely does. AI models can interpret data not just based on its own value in isolation, but based on its relationships to other fields, patterns across other records, even external knowledge. They can figure out that Apple in a product name column probably means the fruit, while Apple Inc. in a supplier column means the tech giant.
And the ability to handle text, that must be huge.
Oh, massive. NLP-powered natural language processing is central here. Large language models, they excel at understanding, processing, generating text. They can automatically spot and fix typos, even in complex free text fields, extract structured info from messy descriptions, and even intelligently suggest missing text values based on the context. Traditional methods couldn't even dream of doing that.
So it learns from the data itself rather than needing this rigid rule book you have to keep updating.
Exactly. That's the adaptive learning part. You can show AI models examples of your data and what the clean output should look like, and they learn the patterns, the relationships. This dramatically reduces the need for writing and maintaining, thousands of explicit, rigid rules.
And it works across different kinds of data, not just neat tables.
Yep, multimodal handling. Modern AI can process structured data, like your typical tables, alongside semi-structured data, like JSON files, and unstructured data like raw text or even documents. This lets you have a much more unified approach to cleaning all these diverse data sources you might have.
Okay, and you mentioned anomaly explanation earlier. Being able to ask why something got flagged, that sounds incredibly useful.
It really would save so much time, wouldn't it? That's the anomaly explanation capability. So beyond just flagging a potential error, some Gen AI tools can actually offer a probable reason or context for why a value seems off. That makes the human review process way faster and more focused.
Okay, let's get concrete. The sources list a whole bunch of specific use cases where AI is already cleaning data. Error detection seems pretty foundational.
Right. AI, especially using NLP, can automatically spot and correct inconsistencies, typos, formatting errors across huge data sets, much more efficiently than manual rules ever could.
Predicting missing data, that feels like a superpower.
It kind of does. Machine learning models can analyze correlations within your data and predict what a missing value is likely to be. Like if a customer record is missing their city, but you have their zip code, AI can probably predict the city based on patterns it sees in other records.
Duplicate detection is another one that just eats up time traditionally.
Oh, AI is fantastic here. Techniques like clustering or using embedding models can understand semantic similarity. They can tell that John Smith, 123 Main Street, and J. Smith, 123 Main Street are probably the same person, even though the text isn't an exact match. Much smarter than simple fuzzy matching.
And fixing data types, like turning text that looks like a number into an actual number.
Yep, data type validation. AI can infer the correct data type and automatically convert it or flag mismatches, like cleaning $1,000 into the numerical value of 1,000. Simple, but saves a lot of hassle.
Outlier detection is critical, but yeah, those simple thresholds miss so much.
Exactly. AI's strength in understanding context and patterns makes its anomaly detection much better at flagging true outliers, like that transaction value that's way, way different from the norm, and it does it in a way that's less prone to false positives compared to rigid rules.
Standardization must be a big one too. Things like addresses or units of measure.
Absolutely. Data standardization. AI can learn all the various ways the same information is represented in your data and automatically convert it to a single, consistent standard format across the whole data set.
And what about checking if data makes logical sense, like within the same record?
That's contextual validation. AI can analyze relationships between fields, like does the hire date make sense given the birth date? Does the product category actually align with its description? It flags illogical entries that might easily slip past simple validation rules.
Okay, and finally, ensuring consistency across different data sets or systems.
Yeah, data consistency. AI can compare related data across different sources, maybe checking inventory logs against shipping records, identifying discrepancies, and maybe even suggesting corrections.
Wow, okay. These use cases cover so much of the traditional data cleaning headache. Where are we seeing this really make a difference, like in specific industries?
The sources give several good examples. In healthcare, AI cleaning is vital. Standardizing medical records from all these different systems, detecting duplicate patient records, improving data quality for research, for diagnostics.
Right.
The stakes are high there.
You need incredibly high accuracy. How about finance? Bet they're using it.
Oh yeah, finance uses AI cleansing heavily for fraud detection, spotting inconsistent transaction patterns, weird login behaviors. It improves data quality for risk assessment models, helps ensure data lineage, consistency for all that regulatory compliance reporting they have to
Right,
do.
compliance is huge. And retail or e-commerce, the sheer volume there must just crush manual methods.
Totally, massively. AI cleans customer data for better personalization, more accurate marketing. It cleans inventory data for precise stock levels, optimizing supply chains. And it cleans product catalog data, which is notoriously messy, coming from all sorts of vendors, enabling better search, better recommendations. Huge impact.
Okay, let's just step back for a sec. Let's compare the core differences between AI and traditional cleaning based on what these sources are showing us.
Yeah, the comparison tables and the sources are really useful here. Traditional methods. They rely on handcrafted rules, filters. AI uses machine learning to discover the patterns.
Right.
Traditional needs manual work or simple stats for missing values. AI can predict them based on learned context. Traditional needs custom scripts for standardization. AI can do it adaptively based on patterns it finds.
So it's really the difference between telling the system exactly what to do step by step versus teaching it how to figure things out for itself.
That's a great way to put it.
Yeah.
Exactly. AI continuously assesses and learns from data quality issues, making it more proactive. Traditional methods, often reactive, need manual audits. And while traditional might be faster per record for super simple tasks, the sources generally indicate AI offers higher accuracy for complex stuff, like text cleaning, deduplication, and crucially, it dramatically reduces the human time spent on implementation and maintenance. That makes it more cost-effective overall.
That shift, moving from endless rule maintenance to like training and monitoring AI models, that seems like the fundamental change here.
It truly is. And AI's knack for learning patterns, it goes beyond just cleaning. It's also revolutionizing anomaly detection.
Right, the second big area.
Yeah. Traditional methods often use these static thresholds like flag any transaction over $10,000, which, as we said, are brittle and generate tons of false positives.
Because what's normal changes all the time, right?
Yeah.
Or a real anomaly might be below the threshold, but just look really weird in context.
Precisely. AI learns what typical behavior looks like, what patterns are normal within your specific data, including all the temporal nuances, the context. It identifies deviations with a much higher degree of accuracy and, importantly, less noise.
The sources mention different types of anomalies.
Yeah, they break it down. You've got straightforward outliers, like that $1 million transaction when the average is 100,000. Then unusual trends or behaviors, maybe a sudden unexplained drop in website conversion rate.
Yeah.
And also underlying errors or data quality issues that just happen to show up as odd patterns.
So how does AI actually enhance detecting these compared to the old ways? Is it just better algorithms?
It's partly that, yeah. AI uses more advanced ML techniques, things like clustering, autoencoders, deep learning that can process complex multidimensional data all at once.
Yeah.
They can spot patterns across many different data points simultaneously, something simple rules or basic stats just can't handle.
Okay.
And they adapt over time as your data naturally evolves. They learn what the new normal looks like.
Looking at that AI versus traditional comparison again, but for anomaly detection, what stands out?
AI gets much closer to real-time detection because its models can process continuous data streams. Traditional often relies on slower batch processing. AI is highly adaptable, learning from new anomalies it sees. Traditional needs those manual rule adjustments constantly.
Right, the brittleness again.
Exactly. AI excels at finding those subtle multivariable patterns hidden in noisy data, while traditional methods are largely blind to them.
And that helps with the false positive problem, getting fewer bogus alerts.
Significantly. By understanding the nuances, the context, AI models can dramatically reduce both false positives crying wolf and false negatives missing the real issue, much better than the rigid thresholds of traditional systems. And importantly, AI can pull insights from diverse data sources, structured and unstructured, to build a more complete picture of normal. Traditional methods usually can't do that.
So, more accurate, more adaptable, better context for spotting the weird stuff. Where are we seeing this in action? What are the use cases?
Key ones include fraud detection in finance, looking for suspicious transaction sequences or odd login patterns,
Hmm.
network security, identifying abnormal traffic flows that might signal an intrusion. In manufacturing, detecting potential equipment failures by spotting unusual sensor readings before they cause a breakdown. And in healthcare, maybe flagging potentially rare or anomalous patient conditions based on looking at all their aggregated data together.
Okay, so AI is tackling the cleaning and the spotting of issues. Now let's talk about tracking the data itself, its journey, data lineage, that third piece.
Right, data lineage. It's essentially mapping the life cycle of your data. Where did it come from originally? What systems did it pass through? How has it changed or transformed along the way? Where
Hmm.
does it end up? You can think of it like the data's full autobiography, detailing every step and every change.
Why is that so crucial? It sounds complex.
It is complex, but foundational for several key things. One is traceability. If there's an error or a question about some data point, Lineage lets you trace it all the way back to its source,
Hmm.
vital for validating quality.
Okay.
Then compliance. Understanding data flow is often a strict regulatory requirement, like GDPR, APOA, and things like that.
Hmm.
Data quality itself, Lineage, can actually show you where in the pipeline data quality might be degrading during transformation.
Ah,
Also, collaboration. It gives different teams a shared map so everyone knows where data comes from. And impact analysis, if you need to change a data source or a transformation step, Lineage shows you everything downstream that's going to be affected before you make the change.
that sounds incredibly complex and, frankly, tedious to map out manually, especially in a big company with tons of interconnected systems.
It is absolutely nightmarish to do manually. And that's precisely where AI offers a potential revolution. AI can automatically discover, generate, and critically maintain these complex lineage maps across all sorts of diverse systems. This capability brings tremendous transparency and accountability. It gives you that auditability needed for regulations, but without the insane manual effort.
So instead of someone trying to manually draw diagrams or sift through endless logs, AI just builds the map for you.
Pretty much, yeah. The comparison is stark. AI provides automatic, near real-time tracking and visualization across various data pipelines, different systems.
Hmm.
Traditional methods, largely manual, rely on a static metadata, maybe parsing logs, or just human input, which means they're prone to errors and get outdated incredibly quickly.
And AI can help document the process automatically too, like where it came from, what happened to it.
Yes, providing data provenance. AI systems can automatically document the source, all the transformation steps, the processing history. Manual tracking is often limited to disconnected logs or maybe some human notes here and there.
Hmm.
AI also helps with error localization. It can automatically trace errors back through the lineage map to find the source system or the specific transformation step where things went wrong. Much faster debugging.
Versioning and audit trails must be way easier too.
For sure, AI enables intelligent versioning. It can automatically recognize changes in data structures or transformations across different iterations. That makes audit trails integrated and efficient. And maybe the biggest difference is just scalability. The AI-powered lineage systems can scale pretty seamlessly as your data pipelines get more complex, handle more volume, manual tracking. It just becomes unmanageable very quickly as data environments grow.
Okay, so across cleaning, anomaly detection, and tracking the data's journey, AI is injecting automation, intelligence, where the old ways were just hitting a wall. How are organizations actually putting this into practice right now? What are the sources saying about real-world use?
Yeah, the sources point to several practical ways Gen AI is being used today. One is AI-powered data profiling. This goes beyond just calculating basic stats like min, max, average. AI can provide semantic understanding. It tries to understand the meaning and the context of data fields, not just their format or value range.
Getting the why behind the data, not just the what, kind of like we discussed.
Exactly. Another is intelligent value standardization, where normalization isn't just based on a fixed rule, but it adapts based on the learned context and relationships between fields. More dynamic. Then there's contextual anomaly detection, which we talked about, finding those subtle issues that only look weird when you see the bigger picture.
And semantic deduplication, going beyond just fuzzy matching to really understand if two records represent the same thing, the same entity, even if they're described quite differently.
Yes, that's a really significant one. Huge potential there. And natural language data extraction. Using LLMs to pull structured data out of those messy, unstructured text fields, which are often a major source of dirty data that was previously just unusable.
The sources shared a pretty compelling case study that pulls a lot of these together, that e-commerce product catalog example.
Yeah, it's a perfect illustration, really. Shows the traditional pain points and how AI can tackle them. So this large marketplace, millions of products listed, wildly inconsistent data coming in from different vendors, descriptions, categories, attributes, you name it. Total chaos. They're traditional, rule-based cleaning. It required a dedicated team of 12 data engineers just to maintain the rules. And adding new product types took weeks because they had to write all new rules.
Just a classic maintenance nightmare, constantly playing whack-a-mole with the data issues.
Exactly. So they implemented a hybrid Gen AI solution. They used LLMs to automatically classify products based on descriptions, even images. They used them to extract structured attributes from those messy text descriptions, applied semantic deduplication to find and merge duplicate listings, and used contextual anomaly detection to flag products with suspicious specs or weird errors.
A multi-pronged AI attack. And the results after they brought AI in.
Pretty significant improvements across the board. This was after just 6 months. They saw an 85% reduction in manual cleaning effort,
Wow.
meaning those 12 engineers could finally focus on higher value work, not just rule maintenance. Product categorization accuracy jumped from about 74% up to 92%. Customer complaints about inconsistent data dropped by 67%.
That's huge for customer experience.
Absolutely. And maybe most impressively, search-to-purchase conversion increased by 43%, simply because the product information was higher quality, more consistent, more findable.
That's a powerful story. Frees up human potential and drives direct business impact. Okay, so this sounds great, really promising. But how do you actually get started? How do you put AI into practice for data quality in your own organization?
The sources suggest a pretty practical approach. First step, audit your current data cleaning workflows. Where are you spending the most manual time? Where are the persistent quality issues that keep popping up? Those are usually the best places to start.
Right, don't try to boil the ocean. Focus.
Exactly. Second, start with simple, high-value use cases. Maybe text standardization, parsing information from free text fields, or just improving data profiling with semantic understanding. Those are often good candidates because LLMs are naturally good at them, and the impact is usually pretty visible, which helps build momentum.
Okay, identify the pain, pick a starting point. Then you need to actually choose the right technical approach. Right.
Yeah, and you have options here. You could use commercial API-based services from cloud providers or specialized vendors. They're often quick to implement, but you have ongoing costs, and you need to think carefully about data privacy sending your data out.
Right.
Or you could deploy open source models on your own infrastructure, on premises, or in your private cloud. Your data stays put, no per query cost after setup, but it requires more infrastructure, more internal expertise to manage.
A dribber lift initially.
Definitely. Or you could fine-tune models. Take an existing open source or commercial model and train it further on your specific data and tasks. This is the most complex option, but it can yield the best results for very unique or specialized needs.
A hybrid approach seems like the most realistic path for most organizations, doesn't it? Mix and match.
Absolutely. Keep using traditional methods for the simple, standardized tasks they handle perfectly well. Use Gen AI for the complex stuff, the contextual challenges, the unstructured data problems. And crucially, implement human-in-the-loop workflows, especially for critical data. Let AI suggest changes, but have a human review and approve before anything gets applied automatically.
That safety net seems important. And like any tech initiative, you have to monitor performance and refine.
Constantly. Track the results. What are the accuracy metrics? How long does it take to process? How much time are you actually saving your data teams? And what's the downstream business impact? You need to measure it to justify it and improve it.
The sources even gave that simple, really relatable example of using everyday Gen AI tools like Copilot, Gemini, ChatGPT for basic cleaning before you even import data into a system like Salesforce.
Yeah, that's a nice practical touch. You can literally export messy data into a spreadsheet, then paste rows into the chat interface, or use the AI features in the spreadsheet and give it prompts. Ask it to fix formats, standardize values, fill in obvious gaps, then check the output and re-import.
So, using tools many people might already be playing with, the source described feeding the AI some problematic rows exported from Salesforce, things like inconsistent location names or weird status values, and just explicitly asking it, hey, can you correct these and make them consistent?
Exactly. And critically, they emphasize you have to carefully check the AI's output for hallucinations, The AI just making stuff up.
Right. Can't trust it blindly.
No way. It
Exactly.
requires clear prompting, maybe giving the AI examples of exactly what you want the output to look like.
Hmm.
But for basic tasks, they found it was significantly faster than doing it manually or trying to write some quick throwaway script.
They did that quick comparison too between Copilot, Gemini, and ChatGPT for a specific cleaning task. What were the main takeaways there?
Yeah, in that particular test, they found Copilot and ChatGPT performed pretty well for the basic cleaning they asked for. Gemini, in that instance, showed a bit more risk of hallucination.
Interesting.
Copilot was noted for providing explanations for its changes, which is really helpful for building trust and understanding why it did what it did. ChatGPT was apparently a bit faster at just generating the output, but the key message wasn't really, this one is best. It was more that you should probably try multiple tools, see what works for your specific task, and always verify the results. Don't just take the first output.
Good advice. So even basic AI tools can lend a hand, provided you prompt carefully and double-check everything. But you mentioned challenges earlier. AI isn't some magic bullet you just install.
Oh, far from it. Definitely not.
Hmm.
One big challenge is computational cost. Running inferences on these large language models, especially at scale, can be more expensive than traditional methods. So you need to think about optimizing queries, maybe using smaller task-specific models where possible, or processing data in batches instead of real time, if that works.
Okay. And explainability, understanding why the AI made a specific change that can be tough with these complex models.
It can. Solutions there include things like requiring the AI to provide confidence scores for its suggestions, maintaining really detailed audit logs of all the changes made, and definitely using those human-in-the-loop workflows for critical decisions where you absolutely need transparency. Then there's the hallucination risk we just talked about.
Right, the making stuff up problem.
Safeguards include constraining the AI's output, maybe only letting it choose from a known list of valid options, applying downstream validation rules after the AI has done its thing, or using ensemble approaches where you get multiple models to agree before accepting a change.
And data privacy is obviously a huge one, especially if you're thinking about sending sensitive customer or business data to external APIs.
Massive concern. Options here include using those on-premises open source models that keep all your data within your own environment. Or, if you use external APIs, thoroughly anonymizing or pseudonymizing data before sending it, or developing custom fine-tuned models that are specifically trained on your sensitive data domains and deployed securely within your perimeter. You have to take it seriously.
It sounds like this whole shift towards AI and data quality is also happening alongside other tech advancements that kind of enable it.
Yeah, definitely. The sources touch on related trends, things like AutoML, which helps automate the building of the machine learning models themselves, data ops methodologies, which promote more agile, automated data pipelines where you can actually integrate these AI steps effectively, and just broader advancements in NLP and machine learning generally are all feeding into this.
Gartner's prediction about data management markets converging by 2028, heavily influenced by Gen AI, that speaks to this broader trend too, right?
Exactly. It signals that this isn't just a niche application, it's becoming central to the future of how we manage data overall.
So looking ahead then, what's the next frontier for AI and data quality? What do the sources see coming down the pike?
They point to some really exciting possibilities. Things like multimodal data cleaning, where AI models can clean data that includes text, images, structured numbers, all interacting together simultaneously. Imagine cleaning product data that includes descriptions, photos, and specs all at once.
Wow, okay.
Continuous learning systems that automatically refine their cleaning rules and anomaly detection models as new data patterns emerge in real time without needing constant manual retraining.
Cleaning-aware data generation. That sounds complex.
It is, but potentially powerful. The idea is generating realistic synthetic data points based on context when data is missing or totally unusable, but doing it in a way that ensures the generated data still meets quality standards and fits the patterns, and moving towards intent-based data preparation.
Intent-based.
Yeah, where instead of telling the AI how to clean the data, you just describe the goal or the purpose of your data use. Like, I need this data ready for a customer churn prediction model, and the AI automatically figures out the optimal cleaning and preparation steps to get you there.
That's a big leap. The ultimate vision seems to be autonomous data quality management. Is that realistic?
That's the long-term direction, yeah. Systems that proactively monitor data quality across the board, automatically apply cleaning or correction steps based on learned rules and contexts, generate intelligent alerts for human review only on the really complex or ambiguous issues, and continuously learn and adapt to the organization's evolving data standards without needing constant human intervention. That's the moonshot, maybe, but it's where things seem to be heading.
So yeah, AI in data quality.
Hmm.
It really isn't just an incremental improvement, is it? It feels much more like a potential paradigm shift. It promises more intelligent, more adaptable, and just dramatically more efficient ways to handle that fundamental, persistent problem of messy data.
Which ultimately translates to freeing up all that valuable time for data professionals, right? Letting them focus on analysis, on innovation, leading to more reliable insights, and hopefully better decisions across the whole organization.
It really fundamentally changes the calculation for anyone who's tasked with getting value out of data. The sources kind of leave us with this key question that I think really encapsulates this whole transformation. Is AI just a tool to improve the efficiency of the data quality tasks we already do? Or does it represent a truly fundamental shift in how we manage and govern data itself?
Yeah, what are the real opportunities here, but also what are the significant risks that come with this AI-driven approach? And maybe most importantly for you, the listener, how can you start to navigate this evolving landscape? How can you capitalize on the opportunities while effectively mitigating those risks in your own work, within your own organization?
It's not just about adopting the tech, is it? It's about thinking critically about what it implies and how it might reshape the very definition of data quality and how we even achieve it.
Exactly. The challenges of data management, they aren't disappearing overnight. But AI offers this powerful new set of capabilities to tackle them in ways traditional methods just couldn't scale to meet. It really does feel like the beginning of a new era for data preparation.